Hello, welcome to this lesson of our study of partial differential equations. So in this lesson, what we'll do is we're going to go through how to solve exam practice questions on classifications of PDEs, especially the second order. All right, so we'll go through some three basic examples. I think it would cover almost all type of questions you'll be able to get under this section. Okay. Alright, so let's start. Now, determine in which region of the xy plane that the following equations are elliptic, hyperbolic, or parabolic. Okay, so originally we know that we can classify second order PDEs in terms of either them being elliptic, hyperbolic, or parabolic. So we have three examples here that we're going to go through. The first one is e to the power 2x usx. Like that. Okay, so I've written all these again, but I just want to show you the questions. This is the third one. Okay, I hope they are cool. Now, to classify a PDE, the second order, we are supposed to recall that we'll have to rewrite or compare the PDE to the general form AUXX plus BUY XY, AUXS plus BUXY plus CUYY plus the rest. The rest are actually not important when it comes to classifying them. Okay, so all that we need is the first three terms, that is AUSX plus BUXY plus CUYY, and that when you have that, then you have to get our B, our A, and then our C, and that we should consider this fact that if B squared minus 4AC is less than 0, then we have elliptic PDE. If B squared minus 4AC is equal to 0, then we have a parabolic. Okay, and the last one is when B squared minus 4AC is greater than 0, which is hyperbolic. Okay, now let's go to solving the questions. Now the first question that we have here, which is e to the power usx, okay, this one, plus 2e to the x plus y uxy, okay, this one, plus e to the 2y uyy plus the remaining. The first three terms are what we need. Okay, so we compare it to the general term uxs plus auss plus buxy plus cuyy. Then realize that our a is equal to 2e to the power 2x, and our b is equal to 2e to the x plus y, and our c is this, okay, e to the power 2y. Now we have to use what we call the b squared minus 4ac to determine whatever we will have or whatever result this will give us. Okay, so to begin with the first one, we said our a was giving us 2e to the power 2s, this one, this is our b, this is our c. So I'm just coming to put them or just substitute them into this expression, okay, and simplify. So our b is simply 2e to the x plus y, so b squared will just be, let me use the white pen, 2e to the x plus y, okay, all squared, and minus 4ac, okay, so b squared minus 4ac, then 4, and our a is giving us e to the 2x, so e to the 2x, and our c is e to the 2y. Okay, if you remember clearly, yes, this is our c, right? Now let's go ahead and simplify this expression. When I square this term, it will be 2 squared, which will be 4, okay, then e to the x plus y, this term here squared, okay, and minus 4 into, now this time they have the same base, so I'll have 2x plus 2y. If I continue simplifying, then I'll have 4 e to the x plus y all squared is the same as e to the x plus y multiplying itself. Okay, actually there's a way of just writing the final answer here, but I want to go through with you so that you understand. And this will be 4e to the 2x plus 2y, and this here will give me 4e to the same basis, so I have to take s plus y plus x plus y minus 4e to the 2x plus 2y. And this whole thing here will give me 4e to the, here if I add the powers here, I have x plus x somewhere, so I have 2x plus 2y, then minus 4e to the 2x plus 2y. So at the end of the day, this whole expression will tend to 0 because they are the same. The two terms are the same, but then opposite in sign, so we just equate them to 0. Once we have 0, it means our b squared here minus 4ac is giving us 0. And what do we say? We said that if you have 0, then the equation we have is a parabolic. Okay, so the first question, that is the first one, this equation is parabolic in nature. So we don't have any x and y here to just consider the part of the xy plane where it will be parabolic. So here the final expression is giving us a single value, which is the 0. So you don't need to consider about the xy plane. You just have to conclude that since b squared minus 4ac equals 0, then the equation is parabolic. So let's go to the second one. Second one has uxx minus 2 sine x uxy minus cos squared x uyy minus cos s uy equals 0. So now with this particular one, if you compare it to the general equation, which we say the first three terms are the important ones, you compare it to auss plus buxy plus cuyy, and you realize that this is your a, which is 1, and this is your b, which is minus 2 sine x, and this is our c minus cos squared s. So now with this particular one, b squared minus 4ac here will give us b is what? Minus 2 sine x. Okay, so I have to square it, minus 4 into a, which is 1, then into c, which is minus cos squared x. So if I go ahead and simplify, I'll have 4 sine squared x, then I think is it minus or plus? I think it's plus, right? We are getting plus, because if you remember, here is minus and here is minus as well. So when I multiply them, I'm getting a plus 4 cos squared x, and I can factor 4 from both terms, and this will give me sine squared x plus sine squared x plus cos squared x, and the whole of this sine squared x plus cos squared x simplifies to 1. So I have 4 into 1, which will definitely be giving us 4. Now this is what? Greater than 0. That means our b squared minus 4ac simplifies to 4, which is greater than 0. And since this is greater than 0, we have what? A hyperbolic equation. So again, here we don't have any x and y coordinates or components in this for us to compare or consider in which part of the xy plane that will give us whatever we want. But then here we have just a value, which is 4, and the 4 is greater than 0, so we have a hyperbolic equation. So with the question 2, this one too is a hyperbolic equation as well. Okay, now the first one gave us a parabolic, the second is giving us a hyperbolic equation. Now let's go ahead and look at what the third one will give, and we know what to do. Okay, so with this particular one, we have only two terms present here, but when you compare it to the general one, you realize that the whole of this coefficient, which is the logarithm of the expression or log of the expression 1 plus s squared plus y squared, will be our a, and then the negative of the whole expression 2 plus, that is this term, 2 plus cos s, will be our c. I think the c, there shouldn't be any uyy here. I hope you understand this. So this is our c, and our b, we don't have any uxy components in the main question, so we have b to be equal to 0. So here b squared minus 4ac here would then become 0 minus, because b is 0, so 0 squared is 0, minus 4 into a is logarithm of the expression, log of the expression 1 plus s squared plus y squared then c is minus of the expression 2 plus cos s. Okay, I hope you understand this. Now the minus here in this is just multiplying the whole of that expression. Okay, let me use the white pen for you. This minus is multiplying the whole expression, so it means I can factor that minus out. Okay, and we'll come and multiply everything, so in the end we have a positive. This is what I mean. I have 0 minus 4 into log of 1 plus s squared plus y squared. Then all of this is multiplying negative 2 plus cos of x. Right, so this negative here can come out, this one can come out of the whole of that expression and multiply this negative again. And the whole of this expression will go to positive log of 1 plus s squared plus y squared, then 2 plus cos s. Now this is what b squared minus 4ac is giving us. Here we don't have a number, so we have to just consider the whatever expression we have here and see the outputs or the outcome of this expression. So now the first thing to note is that this function here, or this expression here, is an even expression or even function, meaning that the output for all the positive values of x and y we put here will still be the same output for all the negative values of x and y we put here. Consider this. If I put negative something here in terms of s squared and you put negative in terms of y squared, we'll square them up. At the end of the day, we'll have a positive number. And then the cos of a negative something is still the cos of the positive. So this whole thing is an even expression. So regardless of which plane or which area we are in terms of the x and y, being it negative or positive, we'll still have the same answer. Now the reason why we check that is because of the logarithm, because the logarithmic function is not defined for negative functions or negative values. So if there was a case that we can put something here to get a negative expression, then we'll have to restrict it and say that that place shouldn't be part, because if it's supposed to be part, then the whole of this expression wouldn't be defined. Now doing that for the first time, we have to again consider what we'll have. Is there any case that this whole expression will give us a negative number? Or is there any case that this whole expression is b squared minus 4ac, right? So is there a case that we'll have something like this, that this whole expression will be less than 0? Is there any case like that? So before you can say that, we have to consider the range for some terms here. Okay, we know that this is not defined on negative, so under no circumstance will we get the logarithm of something to give us a negative. Okay, log of any expression, let's say p, is greater than or equal to 0. This is what you should know. It's greater than or equal to 0. It's only 0 when p is 1. Okay, and then is greater than 0 for p being greater than or equal to 1. Okay, sorry, p is greater than 0 when p is greater than 1. I hope you get this. So we understand that this whole thing wouldn't give us a negative. So let's go ahead and check if the expression in the cos can give us a negative. Okay, or in the expression in the other bracket can give us a negative, for us to be able to say that yes, for these values or for this particular values of x, we'll get a negative. Now here we say that this is not giving us a negative under no circumstance. Then we should concentrate on this. Can this expression 2 plus cos s give us a negative? That's the question we should ask ourselves. If it can give us a negative, then at that point of x where this whole expression will be negative, okay, at that point of s where this expression will be negative, then that will be the point where we'll have to say that the whole of this b squared minus 4ac will be less than 0. I mean, if you're able to find values of x that will make this function or this expression to be negative, then we'll have to conclude that at those points of x, then the expression b squared minus 4ac is less than 0, which will give us elliptic. But then before you can do that, let's consider the range of cos S. So here it demands analytics, so you have to analyze it very clearly. The range of cos S is given as -1, okay, comma 1, meaning for cos of everything is either you get the least you can get is -1, and the greatest you can get is 1. That's the range for cos S. So even if in that cos expression, okay, we have 2 plus something, so even if you have the least one of them, that is a negative, okay, we have -1, 1 as the range. So the cos can go as far as getting to 1 and can come as low as getting to -1. Okay, so let's take the lowest one. If you have the lowest one, then it means you have plus 2 plus -1, that will be 1. And if you have the highest one, that is the cos of whatever, we have 2 plus 1, which will be 3. All of these are positive. I hope you understand. All of these ones are positive. So it means this whole expression here will always be positive. The 2 plus cos S will always be positive because the cos we said has a range of -1 to 1. Okay. And so you have to say that this will always be positive. Now we shouldn't say that because it can also be equal to 0. So we should say that this is no way less than 0. So this whole expression wouldn't be less than 0. So it means it is never elliptic. So that one is out. Now you consider the other case. Is there any case that we will get this being equal to 0? And under which circumstance would log 1 plus S squared plus Y squared be equal to 0? Under which circumstance? Okay. This will only happen when we have S squared plus Y squared being equal to 0. And if I do this, then this means we are talking about the SY plane, so we shouldn't go beyond the SY plane. Okay. If we were talking about a complex plane, then this we can do S squared equals minus Y squared, and that X is equal to plus or minus square root of minus Y squared, and this will give us plus or minus YI. Okay, so if we were to talk about complex plane, then this would work. But here we are talking about the XY plane, so this one wouldn't work. But then when X equals 0 and Y is also equal to 0, then S squared plus Y squared will be equal to 0. Because S is equal to 0, Y is equal to 0. And that point, log of that will give us log 1 plus 0, which will be log 1, and that will be equal to 0. And when log of this is equal to 0, then 0 multiplying everything will be equal to 0, right? So at that point, to X, we are saying X and Y are 0, so that the expression 2 plus cos S will be 2 plus cos of 0, and that will be 1. Cos 0 is 1, that will be 3. So I'll have, let me clean here and then tell you what is happening here. So bear with me, we are just analyzing everything before we conclude. We'll just conclude right now, okay? So here, when X equals 0 and Y equals 0, then B squared minus 4AC, which is the expression given here, will then give us 4 into log of 1, okay, because S and Y are 0, then 2 plus cos 0, which is 1. So in effect, we have log 1 is 0, so multiplying everything, we have 0. So B squared minus 4AC will be 0 only when X and Y equals 0. Now, we also said that it would never be less than 0. That means it will never be negative. So with the other aspect, considering B squared minus 4AC being greater than 0, it's certain because we said that it would never be equal to or be less than 0. This implies that this whole equation for log of 1 plus S squared plus Y squared into 2 plus cos S will always be greater than or equal to 0. Now, it is equal to 0 when X is equal to Y equals 0. I mean, when S and Y are both 0, okay? That's when you have 0. But then, when it's never 0 or when X and Y are both not 0, then the expression will always be greater than 0. Okay, so this means that this is how you conclude the equation, or the PD we are being given. The equation is, since we said it's always greater than 0, but it is equal to 0 when x and y equals 0. Okay, so it's hyperbolic. When it's greater than 0, it's hyperbolic. Okay, so hyperbolic, that is when it will be always greater than 0. Hyperbolic in or everywhere in the x and y xy plane, everywhere, or in the whole plane, everywhere in the x y plane. Okay, xy plane, except, okay, at x equals 0 and y equals 0, which is parabolic. Okay, because we say that at x equals 0 and y equals 0, we have the expression giving us 0, and that is parabolic. Okay, so that is how you conclude. You know that you have to first of all consider if it is an even function or odd function, and also consider which output we will get. Are you going to get a negative output or positive output? If it is negative output, at which point or at which region? If it is a positive output, at which region? And if you are lucky and then the equation does not produce any negative output, then it means the elliptic aspect is out. And if you are lucky that it also don't produce the positive output, then it means the hyperbolic output is out. But here our thing gave us a hyperbolic function or hyperbolic output that is always giving us an output greater than or equal to 0, and it's only equal to 0 when you have x and y being equal to 0. So the equation is hyperbolic everywhere in the xy plane except at x equals 0 and y equals 0, which is parabolic. Okay, so let me give you some hints here. Hints: when you are given alpha uss plus beta usy plus gamma uyx, so realize here and here are different. This ui is this uxy plus lambda uyy plus the rest. All we need is from this term up to the uyy. Now remember that, or note that uxy is the same as uyx. Okay, and this will imply that if they are the same, then I can sum this and this. Okay, this will imply alpha uxy plus, then you have to sum the coefficients of this beta plus lambda or gamma, sorry. Then when you are giving, I'm just giving a hint, when you are giving such a problem, then before you state your a and b and then c, you have to do this, and that your a will be alpha, your b will be beta plus gamma, and your c will be lambda. Then you start continuing. Okay, I hope you understood everything. So this is what I have for you today. Thank you, and if you have not subscribed to my channel, kindly subscribe for more video. And also, if you are subscribed, thank you. Like my video and share to others as well. You can also leave your comments in the comment section for me to read. See you next time.